Alright, hey guys, today we are going to go over lesson 10.3, which is multiplying polynomials. You kind of explored this a little bit yesterday, but now after you explored it, now I'll kind of go over it more formally. So last week we were multiplying things like this, like a monomial times a binomial or a trinomial. So we would do something like this and times it out. Today we're going to be doing something like this. A lot of you guys have probably done this topic in Alex and figured it out. So hopefully this isn't too difficult, but if you haven't, this will be pretty quick and simple. Okay, I do want to show you a couple things with these algebra tiles. I know you saw this problem yesterday, but I want to show you how it works because it's going to help us when we get to something called factoring later in this chapter. Okay, so if I asked you to multiply these two binomials, x plus 2 times x plus 4, you could model it with algebra tiles. And here's kind of how this works. So basically it's saying, okay, if I had a rectangle and I took, and I said one of the side lengths was x. Okay, you can kind of see that, right? And maybe I should highlight it in blue. Okay, one of the side lengths is x right here. And then the other side, and then plus 2. Okay, so this is x long plus 2. The other side is x long plus 4. So you can see that kind of right here. Now you kind of multiply it together, and it gives you the area. So if I do this x times x, that gives me x squared. That would give me an x squared tile. If I did this x times 1, that would give me an x tile. X times 1 would give me another x tile, and so forth. And you would kind of get that the whole area is everything inside of here. That would be the area of that. It says, what expressions could be used to represent the width and the length? Well, the width here, okay, is x plus 2. The length is x plus 4. Okay, and you can kind of see that going across x plus 1, 2, 3, 4, and then x plus 2. So those are the expressions. Now, you also could do this another way. So if you thought of it like this, okay, I could say, all right, x plus 2 and x plus 4. This is called a generic rectangle. It's basically doing what we did up here without using the tiles. Now I would do the same thing. If I just did x times x, that's x squared. Kind of like a multiplication table here. If I did x times 2, that would give me 2x. If I did 4 here times x, that would give me 4x, and then 4 times 2 gives me 8. If you look at this, it actually matches up. I'm going to try to use a different color so I can point this out. I'll use my laser pointer. It matches up. So right here, you see this x squared? That matches up right here. Right here, if you see, now I wrote this the wrong way, but you see these 4 x's, those are right here. These 2 x's are right here, and then the 8 are right up here. So I kind of got the same exact thing either way I did it. So the area of this rectangle is x squared plus, I see 4x and 2x, which is 6x, plus 8. So I just multiplied these two binomials. I'm using something called a generic rectangle. Okay, and I got my answer to be this, x squared plus 6x plus 8. So I went from here to here. These two expressions are equal to each other. So they are equivalent, just two different ways to write it. All right, so again, I realized you did this yesterday, but I want to make sure you kind of understood it. So just kind of watch. It says, well, let's look at what they built here. If I can kind of match that up to a generic rectangle. So this is with algebra tiles, and this is called a generic rectangle. So if you look at this, I just kind of go about by figuring out the side lengths. Well, if the area of this is x squared, this side is x long, this is x long, this is 1, 1, 1. Over here, this is also x long. Okay, if I look down here, this would be negative 1 long, negative 1 long, negative 1, negative 1 long as well. So, and then I can just always make sure like x times x, yep, that's x squared. Negative 1 times x, yep, that's negative x. Okay, so the side lengths here, if I look at this, the top here would be x plus 3, if you can see where I got that from. And then down here on this side, it would be x minus 4. Okay, so if I was going to label that in my generic rectangle, I would say, okay, it's x plus 3 and x minus 4. Now, if I multiply that out, x times x is x squared. X times 3 is 3x. It's just like a multiplication table. X times negative 4 is negative 4x. And then 3 times negative 4 is negative 12. Okay. Now, my entire area then, if I write that out, is x squared plus 3x minus 4x and minus 12. Now I should always kind of combine my like terms, so I end up with x squared minus 1x plus 12. Okay, again, you guys can kind of see that at the picture up here. So I can see my x squared. Okay, that's here where it comes here. I've got positive 3x's right there, negative 4x's right here, and negative 12 ones right there. All right, so if I asked you to find the area of x minus 4 times x plus 3, the answer would be x squared minus x plus 12. So our goal is to get from here to here without having to use this generic rectangle or algebra tiles, and we're going to use it doing the distributive property. All right, so yesterday, you guys kind of got to explore multiplying binomials. They showed you a couple different ways, and one way is you could multiply it out, just like when you learn how to multiply like 54 times 62. You could do it that way. I do not know anybody who does it like this. So again, go ahead if you want to do it that way. You know, just like if I was doing this, and then you put a 0 there, right? And then you kind of go to the 24, 30, 32. You guys know how to multiply it like that. You could kind of do the same thing here. Again, I do not know many people who do it like that, but you could. Okay, method 2 was the horizontal method, and that was basically saying like, okay, I can do this x times this whole thing back here, and then minus, I can do this 2 times that whole thing back there. Okay, method 3 is the area model, where you could do x minus 2 times x plus 6, and then kind of you could do your x squared minus 2x, your 6x, negative 12, and you could get what it equaled inside here. So I would say, okay, well, it's x squared plus 4x minus 12. That would be what I get when I multiply it out. And then the third method is kind of the distributor property, which I'm going to show you today. All right, then this is kind of a new vocab word, but anything that looks like this is actually called a quadratic. Okay, basically a quadratic, here's the definition down here. It's an expression in one variable. You can see this just is working with one variable. It's got an x with a degree of 2. This is the second degree, right? That's called a quadratic. So we're going to be working with the quadratics a lot this chapter and the next chapter. All right, so if you were going to multiply these two binomials out, again, you can have, I'll just show you like letter A, 2 different ways. You could draw a generic rectangle, and I could say, okay, 3x minus 4 and 4x minus 10. Okay, and I could multiply it out like this. So I could say, okay, 3 times 4, that's 12x squared. 4 times that, negative 16x. Here I get negative 30x and 40. Okay, and then you just have to kind of combine it. And it shows, okay, 12x squared. I've got negative 30 and negative 16, which is negative 46x, and a positive 40. And I just multiplied these two binomials out. Now, if I was doing it, another way to do it is with the distributive property. This is how you're most likely going to do it, but if you like the rectangle way, you can definitely use it. So I kind of do the distributive property. I'm going to do the 3x times both things back here. So I'll start with the 3x, I'll take it times 4, which gives me 12x squared. Now I'll do the 3x times 10, or negative 10, which is negative 30x. Okay, then I like to kind of draw my arrows like this. I do the second thing, negative 4 times both of these things. So if I do negative 4 times 4x, it's negative 16x, and negative 4 times negative 10 is positive 40. So again, basically you're doing the first thing times everything in the back, and the second thing times everything in the back. And then, just like we did when we were using our generic rectangles, you just combine like terms. So if I combine these x's, I end up with 12x squared minus 46x and plus 40. So I got the same thing both ways I did it. So you can kind of choose which way you like to do it. So hopefully you tried these yesterday, but if you didn't, we'll get to some more of them today. All right, I just wanted to show you this one because this was on your slides from yesterday. It said check this out. So if you try to multiply this out, you can kind of see what you're getting back here. The only thing that's kind of weird about this one is I got positive 18p and negative 18p. They kind of cancel each other out, and you just end up with 6p squared minus 54. This is still a quadratic because it's got one variable, just p, and it's still in the second degree. I could also just write this as 6p squared plus 0p minus 54. This is going to be helpful. I'll just tell you guys what's kind of coming up. We're going to be able to go from this, and you're going to be able to go backwards to this eventually, this chapter. And that's where it gets a little trickier. So all of this is going to, what we're doing these next couple days is going to help us when we get to something called factoring. All right, so I have two problems on my screen. I'd like you to pause the video, and I want you to try both of them. And then when you're done trying them, you can push play, and you can go ahead and check them. All right, so for the first one, it says she's got a picture frame, and the dimensions are the width is 5y minus 5, and the length is 2y plus 6. And it says, can you write an expression that represents the area of the frame? So two ways you could do it. You could multiply it using a generic rectangle, or you could just multiply using the distributive property, which is how I'm going to do it. So I'm going to do 5y times 2y, which is 10y squared, 5y times 6, which is 30y. If I multiply that out, I get negative 10y, and then back there, I get negative 30. And then the last thing you need to do is combine like terms. So I have 10y squared, plus, if I combine my y's, 50y, and then minus 30. So that would be an expression that represents the area. Now, remember, this is a quadratic because it has, it's got one variable, which is y, and it's to the second degree. All right, so the second one says a rectangle is 6 centimeters longer than it is wide. Its length and width are both increased by 4. It says, can you label the rectangle based on the information? And then could you write a polynomial that represents the area of the larger rectangle? Okay, so if this is the width of the original rectangle, the length is 6 meters longer. So I'll put W plus 6, or 6 centimeters. Okay, then it's both increased by 4. So down here it'd be like plus 4 more. And down here, I still have my W plus 6 plus this little extra 4. Okay, so the total length of the larger rectangle, or the total width, I should say, is W plus 4. And then of this big purple one, times, this would actually be W plus 10. Okay, so if I multiply that out, I would end up with W squared plus 10W plus 4W and plus 40. If I kind of combine that, I get W squared plus 14W plus 40. And there is the area of my larger rectangle, if I had this entire rectangle. Now it says, could you calculate the area of the rectangle if x equals 8 or if w equals 8? So basically, if I plug in 8 everywhere, there's a w. So I would do 8 squared plus 14 times 8 plus 40. Then I would just have to work that out and actually get the number, which I'm not going to do because I don't have a calculator on me. All right, so the last thing I want to show you guys is, what if you're multiplying just other polynomials? So not just a binomial times a binomial. What if you're doing, like if you look at this first one, a binomial times a trinomial? Okay, so two ways you could do it. You can, you could model with a rectangle. So this one, if I was doing it, I could say, okay, I have x plus 3, so I need it to be too long. The other one, it's x squared minus x minus 9, so I kind of need it to be like this. Okay, when I do that, I could do, start filling it in. Okay, and I could start multiplying just like a multiplication table. So if I did x times x squared, that would give me x to the third. If I do x times negative x, that's negative x squared, right? X times x. Then x times negative 9 is negative 9x. Over here, if I do 3 times x squared, I get 3x squared. 3 times negative x is negative 3x. And 3 times negative 9 is negative 27. All right, now you just have to kind of combine all these parts. I see the highest power is x cubed, so I'll start with that. Okay, my x squareds I'll combine. Looks like they're right here. So 3 take away 1 ends up with 2x squared. Okay, took care of those. If you look here, I'll combine my x's, and it looks like I have negative 12x. And then I just have that negative 27 in the back. Okay, now that is one way you could do it. The second way you could do it is you could just use the distributive property. So I would just take this x times my x squared, which is x cubed, x times that, which is negative x squared, x times negative 9, which is negative 9x. Then I would do the second number. I would do the 3 times x squared, which gives me 3x squared. 3 times the negative x, which is negative 3x. And the 3 times negative 9, which is negative 27. If you notice, these are the exact same things here. Then you would just have to combine your x squareds, and then you'd combine your x's. You would still end up with this over here. Okay, so if you're multiplying any polynomials, you can either use a generic rectangle like that, or you can use the distributive property. All right, this will be the last one that I want you guys to try. If you look at this problem, it says I have a cube, and it says it has an edge length of x. So if I start with this cube here, and I told you the side length was x, that means that side would be the x, that means that side would be x. And it says the edge lengths are increased to create a rectangular prism. So it looks like they add 2 to this side, and then here they added 3, and here they added 1. Okay, it says, can you find the volume of this prism? All right, now this is kind of a tricky one. So if you don't know how to find the volume of a prism, basically what you can do is you can take the area of the base, okay? Typically, a lot of times they'll do the base in a darker color. So if I can find the area of the base and then take it times the height. Actually, I don't like how they did that one here. I'm going to use this as the base down here. So I'm going to take the area of this and then times it by the height, since they actually labeled that the height. So this is kind of like a double step one. So I'm going to find the area of this base first. So I need to do x plus 2 times x plus 3. Once I have that, whatever I get there, then I can take that times the height, which is x plus 1. Okay, so whatever I get when I times this, I'm going to take that times my x plus 1. So if I times this out, I get x times x, x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. If I combine some like terms there, I get x squared plus 5x plus 6. Okay, now my next step would be like, okay, hey, I better multiply this out. I'd probably put the shorter one, a little tip. Put that in front always. I like to do it that way. So I could do the x times x squared, x cubed, x times 5x, 5x squared, x times 6 is 6x. Back here, now I'm going to do 1 times everything, which is pretty easy. I get x squared plus 5x plus 6. And then lastly, I'm going to combine like terms. So I start with x cubed. Okay, my squares, I have plus 6x squared. Okay, my x's, I get plus 11x and then plus 6. Okay, this is not a quadratic because this is to the 3rd degree. Okay, this is just a polynomial. And that's what I would get for my volume of this cube. I'd probably put a label, b cubed. There we go. Okay, now with the remaining time that you guys have left, you are going to be trying some problems. I do not expect you to get all of these done because I did not tell you what you had to get done yesterday. So here's what I want you to do. I want you to pick some from this list of problems, so maybe screenshot this, and work the rest of class. If you get them all done, awesome. If you get half of these done, fine. But you need to be trying these during class. Okay, so I'd at least like you to try, make sure you get to some of these ones and some of these ones. Probably some of these ones too. Just at least do like a couple from each of the sections with whatever time you have left. Tomorrow we will keep practicing this and I'll answer questions. If you guys need help, you can go on the class kick and I can help you as well. So just put your hand up in class kick if you have questions, or you can ask your group. But you are going to be trying some of these. They are posted in Schoology. Again, take a screenshot of this, and for the rest of the period, you are practicing with any of these problems.